All right, let's look at a couple of these problems. Please do pay attention to how I'm writing these solutions, not just the math itself, but think about how I'm presenting it and so on and so forth. So first, we need to start with the integral of ln of x over x to the third, and we're integrating with respect to x. A couple of things I saw quite frequently were people writing integral signs with no dx's or dr's or dv's at the end. Uh, that's not optional. That's a big no-no. The moment you write an integral, you're saying, hey, start integrating the thing that I'm about to write. So if you write integral of x squared, you have to tell me what I'm integrating with respect to. So imagine like a hardcover book. The book has a front cover, but it needs to have a back cover as well. So this is not an optional thing. This is notationally required. It's a mandatory part of writing the solution. Okay, so now we think. I know that this is a parts problem because it was assigned in the parts section, but let's think about what it couldn't be. So it's not a product, so maybe parts doesn't come up immediately. But if we have a product, we should be thinking of chain rule first and parts next. If it's a quotient, we should be thinking of log. The log rule, we should be thinking of inverse trig. And in this case, the derivative of the bottom is not on top. So the log rule is ruled out. There are no inverse trig. So the inverse trig means arcsine, arccosine, arctangent. So that's gone as well. And as of right now, these are the only two things that we really know how to deal with quotients. That means I'm going to have to rewrite this as a product. So if I do that, I can say this integral is equal to the integral of x to the negative 3 times ln of x with respect to x. Notice I'm writing north to south, not east to west. Okay, so now we have a product. Now we can say, okay, is this a chain rule problem? Is this undoing a chain rule? And that will always be the case if the derivative of part of the problem is in the problem itself. That means take the derivative of x to the negative 3. Using power rule, you're going to get negative 3x to the negative 4. That's not in the question, so this is not going to be the derivative of the inside. If I take ln x to be the inside, well, the derivative of ln x is 1 over x. I don't see that either. So chain rule or reversing chain rule is not an option. Then we say parts. Okay, parts means we have to think of LIATE. Log should be the first thing that is set equal to u. So let me try. I have no idea whether parts is going to work here or not, but let's try parts. So we say we let u equal to ln x. Then du dx is equal to 1 over x. And du is equal to 1 over x dx. All I'm doing is moving this dx over to the other side. But again, you're telling me in words that you're letting u equal to ln x. And then you're saying as a result of that, the derivative of u with respect to x is 1 over x. And also, if we move the dx over to the other side, du equals 1 over x dx. So these are the two things I care about here. That's the first thing. And then the second thing is this. I need a u and I need a du. We have those two things. And I'm going to say also let dv equal to, well, the other function, x to the negative 3 dx. Quite a few of you didn't write the dx there. Incorrect. Because you're saying this portion is u. Everything else has to be dv. You cannot just say, oh, this is dv. Well, then what about dx? Where does that go? You have to account for the entire thing that follows the integration sign, symbol. Okay. Well, if this is what my dv is, dx, then v will be the antiderivative. So you anti-differentiate both sides. So the antiderivative of x to the negative 3 using power rule would be add 1 to the power So -3 plus 1 is -2. And you divide by the new power, divided by -2. So now we have all four pieces to parts. So now you can say by parts or by integration by parts, tell me which technique you're using. So by parts, we know, list the theorem. U dv is equal to u times v minus integral of v du. If you write that, it's not to make me happy, it's to benefit your own self, because now you know exactly what to plug in where. So this means I'm going to write underneath it u, well, u was ln of x, times dv. dv is x to the -3 dx, which is exactly the original problem that we were trying to solve. I just rewrote this in a different order, but the product means it's still the same thing. 3 times 5 is the same as 5 times 3. Equals u times v. Well, u is ln x times v is x to the -2 over -2. Minus, because that's what parts tells me, the integral of v, which is x to the -2 over -2, du. du is 1 over x dx. Equals. Notice I'm lining up my equals. Even here, well, here, I guess here there's only one equal, but if there was something else that I was going to do, I line up my equals underneath it. Here, I'm going to continue. Well, this is just going to be, I can rewrite this so that the x is at the beginning. X to the -2 times ln of x over -2. You could have just copied this down entirely. There's no difference whatsoever. Typically, by convention, we write x's first, so that's why I'm doing that here. But there's no requirement. You could have just copy-pasted exactly what you have above. Minus. Now, this, I don't want to integrate this thing as it sits, so I'm going to simplify it first. So I'm going to simplify this into 1 over -2x squared times 1 over x. So all I'm doing is moving this term to the denominator. I still haven't taken the integral. That's why the integral and the dx are still there. I'm going to rewrite this again. X to the -2 times ln of x over -2. Now I can take this negative and combine them to get a positive. So plus integral of 1 over 2 x cubed with respect to x. X squared times x in the denominator. We can glue those together and get x cubed. I still have not taken the integral. So I have x to the -2 ln x over 2 plus, now to take the integral, I'm going to move x to the -3 to the numerator and rewrite it as the integral of x to the -3 over 2 dx equals x to the -2 ln of x over 2 plus, now we're ready to integrate this. So we add 1 to the power, x to the -2, dividing by the new power. Well, the 2 was already there in the denominator. That means anything I'm dividing has to go next to it. So this 2 is the guy that was already there. This -2 is coming from the integration. Plus c. Now, if you haven't yet, or if you don't remember, pause this video, go look for the map of Oklahoma. Anytime you're at mathematics, at least in my course, the map of Oklahoma should be in your head. And the map of Oklahoma looks like this. It's got this little bar here, and then it basically becomes like this big block here. So you start with whatever you're looking for, and then you say, well, this guy is equal to this, and this is equal to this, and this is equal to this, which is equal to this, and finally that's equal to that. It should be linearly going north to south. If you give me half measures or if your solutions are all over the place and I can't figure out which direction your solutions are moving in, you lose points for not being readable. And again, if you're doing homework problems, it's to your benefit to do this in an organized fashion so that when you go back to this to review before a quiz, at least you know what happened after or before each step. And then if you want, this part is not relative or necessary. So here you can summarize and say thus integral of x to the negative 3 ln x, which is what we started with, is equal to x to the negative 2 times ln x over, I lost a negative here, over negative 2 plus, and again, you can leave this as is, or you can rewrite this as negative 4. You don't get any points, you don't lose any points. You could have just left this as 2 times negative 2. That's perfectly fine. Hopefully that gives you, period. Hopefully that gives you an example of how you should write solutions for your homework. When you're doing problems in class, put in the words. They're there to help you read these problems, or read the solutions rather. Try to keep this little checkbox thing off to the side. Now, this list will grow as we learn about trig integrals and trig substitution and improper integrals. So the types of things you'll be expected to know how to do are, well, that list is going to continue growing, but not yet. Hopefully that helps.